Now see the part 2 of solid state. Part 2 of solid state. Question number 9. A structure of mixed oxide is cubic close packed. So there is mixed oxide which follow the CCP. CCP full form is cubic close packed. Cubic close packed. Right. So cubic unit cell of mixed oxide is composed of oxide iron. Right. So cubic unit cell is composed of oxide iron. 1/4 of the tetrahedral voids. So there is 1/4 of tetrahedral voids. Right. Are occupied by divalent metal. Are occupied by divalent metal. But right, that is called A. And octahedral voids are occupied by monovalent atom. Divalence means its valence is 2, right? That is, next is octahedral voids. Octahedral voids are occupied by monovalent atom. So B type element is monovalent. Monovalent atom B. Formula of the oxide is, so you have to find the formula of the AB or the compound. So see, so number of atoms in cubic close packed is 4. So total number for cubic close packed is atom will be 4, right? And it is of oxide, right? So it will be 2 minus. So number of tetrahedral voids is, it is 2n types. As we know, atom is 4, right? So what will be the tetrahedral voids? It is 2n and octahedral is n, right? So n value we know, that is 4. And for the tetrahedral it is 2 into 4. It will be 8. Understood? Right. So now, and it is also 1/4 of that one. So it will be how much? It is 8 into 1/4. So it will be coming out as a 2, right? And it is divalent. So it will be 8 2 plus, because it is at the position of cation, right? And number of octahedral bonds we have got, right? That is 4. And it is of the monovalent. So B will be B plus. Understood? Now take the ratio. Ratio of ions will be O2 minus, that is oxide, and A2 plus and B plus. We know the value of each one. O2 minus is 4 atoms, so it is will be 4. And A2 minus is 2. And B is 4, right? So what will be the simple ratio? If you divide by 2, you will get 2 ratio 1 ratio 2, right? So it is A. So O2 minus we are getting as 2, and for A2 plus we are getting 1, and for B plus we are getting 2. Now swap the oxidation. So you will get what? Tell me. 242, right? 212. So it will be A1, right? And B2 and O2. So this will be the general formula of the given for compound, that is in the form of oxide. Formula of oxide, right? From where we have got this one? We have just simply multiply with this one. Here 1, this will be 2, and B will be 2. So this will be the formula, right? So please write the explanation. Now look at the 10th sum, that is 10. So which of the following statement is not correct? It is talking about correct, incorrect statement. So see. So number of carbon atom in unit cell of diamond is 4. So it is correct, right? So first option is correct. Carbon also contain 4 atoms of carbon, right? Next option is number of Brevis lattice in the crystal can be characterized into 14. So crystal unit cell will be 14, right? So now see the fraction of total volume occupied by the atoms in primitive cell is 0.48. So let's talk about it. C option. So for the packing fraction of cubic unit cell, it is given by the formula F equal to Z into 4 by 3 pi r cube divided by A cube. What is A? A is your edge length of the cube and R is the radius of a sphere atom. Radius of sphere atom. Sphere atom, right? Because this is your cube, right? This is called A, right? If we put here atom, so radius of this atom will be R. Understood? So efficiency of packing in cubic. So in simple cubic or cubic simple, it is also called as primitive cell. Primitive cell. So it will be equal to pi upon 6. So it will be coming out as 0.52. It means 52% space we occupy in simple cubic, right? So unoccupied will be how much? Unoccupied space will be 100 minus 52. So it will be 8. 9 minus 5 is 4. So unoccupied space is 48%, right? So it is telling that in option C it is occupied is 0.48, but it is unoccupied now, but that's why statement is wrong, right? So please write the expression. It is asked in 2008. Now see, look at the question number 11. Fraction of total volume occupied by the atom present in simple cubic. So it is asking about the fraction of total volume, right? So in simple cubic. Just now we have find, right, how much it is coming out. It is 52% now. Volume occupied, right? So you have to just convert into other form. So let's see. So how much it will be coming out? It will be pi upon 6, right? So see, fraction of total volume occupied by the atom in simple cubic, we know. So please write this answer only. In the previous class, I have told you to remember the volume occupied of each type. So it is asked in 2007. Write it down fast. Now look at the question number 12. In FCC, face-centered cubic, unit cell is shared equally by how many unit cell? Equally, it is asking about equally. So it is shared equally by 6 faces of different unit cell, right? So in FCC, total 6 faces are there, right? So unit cell is shared equally by 6 face. Please write this statement. Faces of different unit cell. Different unit cell. Asked in 2005. Now see the question number next 13. A compound formed by the element X and crystalline in cubic unit cell in which X are at the corner of cube, right? So X is at the corner of cube. And Y are the faces. And Y atom is at the face. Atoms at face. Asked in 2004. See the explanation. So this is at the corner, right? So this is your cubic unit cell in which atoms are placed at the corner. So there are total 8 corners. So contribution of this atom, this one, is 1 upon 8. So total how many atoms are there? 8. So the total atom will be become 1. So this is your x value, right? So it is at the corner. So x value will be 1, right? So now see, for y, it is at the faces. So total 6 face and contribution of face is 1 upon 2. So it will be 3. So we know the formula xy 3 because x value we have got 1 and y as 3. So this will be the formula xy 3. Now look at the question number 14. When jade convert from melted state to its state, it's zinc. So it is talking about zinc. Zn4 zinc converts from melted state to the solid state. It has SCP structure, HCP, hexagonal cubic close packing. Hexagonal cubic closed pack. Right. Then find the number of nearest atom, you have to find it. So in cubic closed pack had the coordination number equal to 12. So please remember the coordination number for hexagonal. It is nothing but it is equal to 12. So this is the point you have to write just. Now look at the question number 15. At cations and anions combine in crystal to form the following types. So when cation and anion in a crystal form, so it is electrostatic force of attraction which exists equally or positively charged, right? That is called ionic bond. So the bond formed between cation and an anion is called ionic bond. It is called ionic bond. Now look at the question number 16. So in cube of any crystal, A placed at the corner. So A is at the corner. B placed at every center of the face and B is at the face. The formula of the compound will be. So it is very simple. We have solved previously, right? So the corner 8 into 1, 8. So it will be 1. And for the B faces, 6 face contribution is 1 upon 2. So 3. So A will be 1 and B will be 3. So formula is AB3. This question is repeated, I think. Please write. Now look at the question number 17. In crystal of which of the following ionic compound would expect maximum distance between the center of cation and anion? So what is the distance between cation and anion in crystal ionic compound? So in cesium plus ion has a larger size. So cesium plus is larger size, has larger size than lithium plus and I minus, has larger than F minus. So I minus is here larger than F minus because in group 17 it comes fluorine, chlorine, bromine, iodine. So this is at the down part, down atom, right? So atom is larger than fluorine. So the maximum distance between the center of cation and anion will be cesium and I. So this will give the maximum large in set. So please write the formula CSI. Now look at the 18th sum. So intermetallic compound lithium silver crystalline in cubic unit cell in which both lithium and silver have the coordination number of 8. So both having coordination number is equal to 8. Crystal class is, you have to find out the crystal class, which class it belongs to. So BCC consists of 8 atoms at the corner and 1 atom at the center. So answer will be BCC, face centered cubic, right? So it follow BCC. BCC, write the full form, body centered cubic, right? In which lithium plus is at the corner and Hg will be at the body. The body of cubic unit cell. So please write it down. Now look at the question number 19. In face-centered crystal unit cell, how many atoms in unit cell? So in face-centered cubic, FCC full form is face-centered cubic, right? So in face-centered cubic unit cell, there are total how many atoms at the corner? 8, right? So contribution will be 1 upon 8, 1. So this is for corner. So total 1 atom is there, 1 atom at the corner by combining 8 corners, right? So coordination number of 6 faces will be how many? So let's talk about the face. So total 6 face. So contribution will be 6 into 1 upon 2. So it will be the 3 atoms. So total how many atoms are there in the FCC? 1 plus 3 is 4. So total number in FCC is 4 coming out, right? So please remember this one also, and I will give you the short form also. In simple cubic, contribution is 1, and in BCC it is 2, and in FCC 4. You can directly just remember it, right, when it is asked. So these are the 3 main points for the contribution or coordination number. Now look at the next question number 20. Pure crystalline substance on being heated gradually first form a turbid liquid at the constant temperature. Still at higher temperature, turbidity completely disappears. Their behavior is characteristics of substance forming, right? So liquid crystal on heating become first turbid, right? So you have to just remember the points. So suppose liquid crystal is there, so it converts into turbids, right? And then on further heating completely disappears. So if you heat further, it will disappear, right? So this is the main point. You have to just remember in question number 20, right? Now look at the question number 21. In the fluorosite structure, fluoro, right, structure, coordination number of Ca2 plus coordination number of calcium will be. So in fluorosite formula will be CaF2. A structure coordination number of Ca2 plus is 8, and in F minus it will be 4. So this will be the formula for coordination number. Calcium is 8 and for this one is 4. So it can be written as Ca, formula is CaF2, no? Now look at the question number 22. In orthorhombic system, axial ratios are A equal not equal to B not equal to C. So it is talking about axial ratio, right? And axial angles. So if all sides are not equal for orthorhombic, it is given orthorhombic system. Orthorhombic system. So sides are not equal. So what will be the answer for angle? So in orthorhombic, please remember all the angles are equal. So alpha, beta and gamma are equal to 90 degree, right? So you can draw the structure like also, right? Suppose I am taking this point. So this will be the x-axis, y-axis and this will be the z-axis. So this is your A, B and C, right? So these are the sides and angle is alpha, beta and this is your gamma. So angles are equal but sides are not equal for orthorhombic. So remember these main points. Now look at the question number 23. Most crystals show good cleavage because their atoms are and molecules are. So, so the crystals show good cleavage because their constituent particles are arranged in plane. So when atoms or particles are arranged in plane, then it show the most breaking. Arranged in plane. So write the this point. Now see the first point. Iron exhibit BCC structure at room temperature. Right. So iron is following the rules BCC at room temperature. So this temperature will be like suppose 25 degrees Celsius. Right. So above 900 degrees Celsius, it transformed to FCC. When it is heated to above 900 degrees Celsius, the ratio of density of iron and at room temperature to that of 90 degrees Celsius. So you have to find the ratio of density. Here density will be rho 1, this will be rho 2. Molecular mass and atomic radius of the iron remains constant with this temperature. It is asked in 2018. So it is asked in 2018. So calculate it. So there is two cases, right? First case is BCC. BCC. So it is body center cubic unit cell, right? So BCC for relation is 4R equal to root 3A. A equal to 4R by root 3. And for face centered cubic, 4R equal to root 3. 4R equal to root 2A. Root 2A. So what will be the A here then? It will be 4R by root 2. And here it is A equal to 4R by root 3. Right. So for finding the density, we use the formula, density formula. So it will be density of BCC divided by density of FCC. It is equal to Z of BCC into capital M, that is molar mass, divided by Na into A cube divided by ZFCC into molar mass capital M divided by Na into A cube. So I will explain each term. So this is your coordination number for BCC. Capital M is right here molar mass, right? And capital Na is Avogadro's number, and A is your edge length, right? So we know the value now. So for coordination number, for BCC coordination number is 2. For FCC coordination number is 4, as I have told earlier, right? So put the value. Coordination number is 2. Here molar mass is same. So that will be cancelled, right? So this and this will be cancelled. Avogadro number part is also cancelled, right? So it will be 2, right? The 1 divided by Na is cancelled, right? So put the value of A value. A for BCC is this one and for FCC is this one. So it will be 4r by root 3 whole cube divided by 4r by root 2 whole cube, right? So please simplify this one and write the coordination number for FCC, face centered cubic. It is nothing but it is 4, right? So that will be coming upward, right? Here 1 coordination number is there. So there is 1 divided here, right? So it is 4. 4 will be upward. So please solve this one. So you will get, I will show you in the next slide. So formula is, you have got the, so it will be 2 divided by 4r by root 3 whole cube divided by 4 divided by 4r by root 2 whole cube. So this is cancelled by 2. So it will become 2. Now this will be 1 upon 4 cube r cube divided by 3 cube. 3 cube is 3 into 3 divided by 2 divided by 4 cube into r cube divided by 2 into root 2, right? Now cancel the term which is common, right? So these 2 and these 2 will get cancelled. So what will be the answer then? Tell me. So we are getting, so 3 will be upward. So it will be 3 by root 2, right? And 3 will be upward. So it is also 3 divided by 4. How much? Coordination number written? You have written here 4 now. So it will be 3 root 3 here remaining, and this is 2. Cancel this 2. So we have cancelled 1, 2, right? If you want to multiply, then you can multiply these 2 also. That will be multiplied, not cancelled. So it will be 4. So answer is, density for the BCC and FCC is, answer is 3 by 4 root 2 by root 2. Or in simple form, it can be written as 4 by 3 under root of 3 by 2. So this will be the density of BCC divided by density of FCC, face centered cubic, body centered cubic. Now see the second sum. It is asked in 2016. Lithium has BCC structure. So lithium has BCC structure, body centered cubic. Density is given. So for BCC, density is 530 kg per meter cube, right? Atomic mass is given. So atomic mass is given, that is 694 gram per mole. So calculate the edge length. Edge length you have to calculate. Avogadro number value is given 6.02 10 raised to 23 per mole, right? So use the direct formula, density formula. So density is nothing but Z into atomic mass divided by Na into A cube. So it will be A cube equal to Z into atomic mass divided by Avogadro number into density. Put the value 2 into 6.94. Coordination number for BCC is 2 now. So it is 2 into 6.94 divided by 6.023, 10 raised to 23 into 0.53. So it will be coming out as 43.5 10 raised to minus 24. So take the cube root. So A will be 352 10 raised to minus 10 centimeter. It is equal to 352 picometer. Right. So this will be the answer. Join करो log